Hello everyone. In this video, we'll talk about parallel computing, mm, the era of parallelism. So basically, the number of devices are increasing proportional to the technology. As in the era of AI and IoT, there are many devices. In order to serve those devices, we need to do more and more computation. And there are mainly two reasons where results to give the existence to the parallelism. That is, the Lennard scaling is getting to an end. The Lennard scaling states that the as we decrease the size of the transistor, their power should be constant. And the Moore's law is also getting to end. The Moore's law states that for every 2 years, the number of transistors that can be placed in a chip is getting doubled. So, because of these two laws are not working, we need to do parallel computing. So, in order to achieve parallel computing, we need to coordinate these resources with each other to achieve higher performance. So, the parallel computing in theory looks like this, but in practical, it looks like this. So, as when we say that there are multiple processes executing at the same time, we need to synchronize safely and efficiently because these multiple processors are use some shared states. So we need to synchronize them. Okay. Um, so there are multiple resources here. So basically, these resources are categorized into two types: shared resources and exclusive resources. The shared resources are the resources that can be shared by multiple processes at the same time. And the exclusive resources uh, is shared by the process, by one process, only one time. So, in order to prove the synchronization, there are mainly two methods: log based and log tree based. So, we'll discuss it about it later. And when it comes to the challenges in the concurrency, first one, interleaving. Interleaving means when multiple threads are executing at the same time, they can be interleaved with each other. Means the execution can be overlapped. So we cannot say that this will execute first and this will execute next. And the second challenge is optimization by hardware and compiler. So when we execute a program, first we need to compile it. In the compiling process, our compiler will try to optimize our code. To optimize our code, uh, there is a chance that our compiler reorder our instructions. So in parallel computing, these reorders can also affect to the final computation. So these two challenges causes the non-determinism. So we need to control this non-determinism. So to control the non-determinism, we need to enclose these two low-level non-determinism by a safe API. This API is a high-level one. So most people need to understand the API, not the implementation. So these APIs are implemented by using log-free data structures and some synchronized patterns. So basically, there are two modes of inferencing. One is easy one and another is difficult one. And the easy one is comes with locks and conditional variables. This is simple, and when the parallel computing needs more and more devices to be completed, more and more process to be completed in parallel. This comes to an issue. So, and the difficult one is lock-free concurrency. So, this lock-free concurrency is, deals with semantics and reasoning principles, and we use some synchronization patterns. And by practice, we use some lock-free data structures to implement this. So, the advices for the concurrent programming is the easy one is easy to study. And if you are new to the concurrency, you need to learn the easy first. We only go to the hard one only when it's required. As we say that premature optimization is the root of all evil. That's, that means we only want to improve our code only when it's required. We don't want to do a best optimal code at once as our requirement suggest and needs it. We need to optimize our code proportionally. So, and the typical concurrency is not the typical once you understand the theory. So, in order to understand the typical part, you need to understand the theory. But understanding this theory is different. Here, the key is controlling the right amount of non-determinism. If we control too much amount of non-determinism, then we get the scalability problem. If we control it too less, then our program may be correct or not. So basically, they are, as I said, that they are lock-based concurrency and lock-free concurrency. So in this lock-based concurrency, there are multiple threads are executing at the same time. So in order to conclude, it means that shared memory, it means shared resource. So these resources are accessible by the multiple threads. So when multiple threads are interleaving with each other, that to share the same memory, one thread can overlap with another thread. So we need to control this by using a lock. So basically, this lock-based concurrency is achieved by lock acquire and lock release. So to access the shared resource, first we need to acquire it, and uh, then after using the resource, we can release it. So the acquiring states that if one lock is acquired by a thread, then no other thread can access the lock until and unless it is released by the lock, lock that is acquired. So, as we say that these lock-based countries is easy because previously we had discussed about challenges in the concurrency, means the causes and unwanted determinism. So, there are mainly two challenges as I discussed earlier, thread interleaving and instruction reordering. So, thread interleaving means we are stopping, means we are controlling the thread interleaving by by using the acquire and releasing points. As I said earlier, if one thread is acquired to a resource, no other thread can access it until and unless it is released by the same thread. So in this way, we are controlling the interleaving of thread execution. And the second thing is instruction reordering. As I said earlier, the compiler can reorder the instruction uh, as in order to optimize the code more efficiently. So here thread A strictly releases before thread B acquire. The thread B can only acquire when thread A release it. So this lock reduces the non-determinism to the minimum. And this lock-based concurrency can be achieved by the low-level APIs that lock acquire, that locks until acquiring the lock, and lock releases the acquired lock. And the challenge is this lock-based conference is extremely error-prone. Means here users should access a resource only when the lock is acquired, held. If the lock is not acquired, then the user does not want to access the resource. And the second thing is, if a thread is acquired the lock, the thread can only release the acquired lock of it. It can't release the lock that is acquired by the another thread. So these causes the API as an extremely error prone, and the programmer should always consider with the API, and there are typically many bugs under the hood. So, but the thing is, this is very simple and easy to use. And the benefit of this high-level API is programmers no need to worry about the misuses, and bugs are unlikely to be happen. So, so we are enclosing this to a high-level API. Means here the low-level APIs are acquire and release, and the high-level APIs of the lock are such as logguard, mutex, and etc.